What is the liquefaction of the soil? Explain the detail under which liquefaction is most likely to occur. The liquefaction is the phenomena in which saturated, loose, cohesionless soil, especially sand or silty sand, loses their shear strength and behaves like a liquid due to the sudden increase in the pore water pressure under the dynamic load, such as an earthquake. Mechanism: earthquake vibration causes soil particles to rearrange. Pore water pressure increases, effective stress decreases. When effective stress approaches zero, the soil loses its strength and behaves like a liquid. Effective stress equation भनेको sigma dash is equal to sigma minus u, where sigma dash is equal to effective stress, sigma is equal to total stress, u is equal to pore water pressure. As u increases, sigma decreases, causing liquefaction. Condition favoring liquefaction. Liquefaction is most likely under the following condition: loose sandy or silty soil, uniformly graded soil, fine sand and non-plastic silt are highly susceptible. Fully saturated soil, water-filled void generate excess pore water pressure during the shaking. Strong and prolonged earthquake shaking, magnitude generally greater than 5.5 with the sufficient duration. Forms a shallow groundwater table. High groundwater keeps level keeps soil saturated. Biomass of poorly compacted or recently deposited soil, river deposit, reclaimed land, beach, sand, and hydraulic fields are more vulnerable. 6. Mass or low confining pressure. Liquefaction commonly occur at the shallow depth, approximately 10 to 15 meter. Effect of liquefaction. Optional extra point में के लेख्न सकिन्छ भने settlement of building, tilting of the structure, sand, well, lateral spreading, अनि failure of the foundation, retaining wall and embankment. हामीले फिगर चाहिँ earthquake हुन्छ, earthquake आएपछि increase in pore water pressure हुन्छ, decrease in effective stress हुन्छ, loss of shear strength हुन्छ, soil behaves like a liquid हुन्छ. Conclusion: liquefaction is one of the most damaging geotechnical hazard during the earthquake. Proper site investigation, soil classification, drainage improvement, and suitable foundation design are essential to minimize the risks in the seismic region such as Nepal. Question number 2. Explain the different working stress method and limit state method and discuss why limit state method is widely adopted in modern structure design. Difference between the limit state method and working stress method. Limit working stress method based on elastic theory. Limit state method based on ultimate strength and serviceability. Working stress uses working load अथवा service load. Limit state method uses factor or ultimate load. Use factor of safety on material strength. WSM भनेको use partial safety factor on the both load and materials मा limit state method. Ensure stress remain within the permissible limit हुन्छ. यो वर्किङ स्ट्रेस मेथडमा यता चेक बोथ लिमिट स्टेट अफ द कोल्याप्स एन्ड लिमिट स्टेट अफ सर्भिसेबिलिटी हुन्छ. कन्जर्भेटिभ एन्ड द अनइकोनोमिकल हुन्छ यतापट्टि डब्लुएसएममा, यतापट्टि मोर इकोनोमिकल एन्ड रियलिस्टिक हुन्छ एलएसएममा. सुइटेबल फर द सिम्पल स्ट्रक्चर हुन्छ एलएसएममा. डब्लुएसएममा यतापट्टि हुन्छ सुइटेबल फर आरसिसी एन्ड स्टिल स्ट्रक्चर हुन्छ एलएसएममा. When a limit state method is widely adopted, the limit state method is preferred because provide higher safety by considering the uncertainty in the load and material strength, ensure serviceability such as load on the deflection, cracking and vibration, economical design leading to efficient use of material, more realistic as considered to the actual behavior of the structure up to failure recommended by the modern design code such as IS 456 2000, IS 8 से 2007 and NBC acceptance 2020. The working stress method is simple but conservative, whereas the limit state method provides the balanced approach by ensuring the both safety and serviceability. Therefore, Limit state method has become the standard method for the modern structure design भनेर भन्न सक्छ. Explain the type of the bridge and their selection criteria based on the span length site condition, discuss in their details and various load and force acting on the bridge such as live impact, wind, longitudinal and lateral force. Type of the bridge selection. Type of the bridge based on the span भनेको up to 10 मिटर. टाइप अफ द ब्रिज अप टु 10 मिटरमा स्ल्याब ब्रिज 10 देखि 30मा बिम अथवा गर्डर बिम 30 देखि 100मा ट्रस बिम 100 देखि 250मा आर्क बिम 150 देखि 500मा केबल स्टेप ब्रिज अनि अब 500मा सस्पेन्सन ब्रिज. यता छ टिपिकल युज. स्ल्याब भनेको स्मल कल्भर्ट एन्ड ड्रेनको लागि, बिम भनेको हाइवे एन्ड रुरल रोडको लागि, ट्रस ब्रिज भनेको रेलवे एन्ड हाइवेको लागि, आर्क ब्रिज भनेको डिप भ्याली एन्ड जजको लागि, 150 देखि 500 केबल स्टेप ब्रिज वाइड रिभर इन अर्बन क्रसिङको लागि, अनि अब 500 भनेको सस्पेन्सन ब्रिज भेरी लङ रिभर क्रसिङको लागि. सेलेक्सन क्राइटेरिया बेस्ड अन द कन्डिसन. द टाइप अफ द ब्रिज डिपेन्ड अन द स्प्यान लेन्थ. सर्ट स्प्यान भनेको स्ल्याब अर गर्डर ब्रिज, मिडियम स्प्यान भनेको ट्रस अर आर्क ब्रिज, लङ स्प्यान भनेको केबल स्टे अर सस्पेन्सन ब्रिज. फाउन्डेसन कन्डिसन. स्ट्रङ रक छ भने आर्क ब्रिज सुटेबल हुन्छ, अनि विक सोइल छ भने गर्डर ब्रिज इज विथ द पाइल फाउन्डेसन. रिभरको क्यारेक्टरिस्टिक्स. विथ अफ द रिभर, वाटर डेप्थ, फ्लोड डिस्चार्ज र स्कार. टोपोग्राफी. प्लेन एरिया छ भने बिम ब्रिज, डिप भ्याली छ भने आर्कर सस्पेन्सन ब्रिज हुन्छ. ट्राफिक रिक्वायरमेन्ट भनेको हाइवे, रेलवे, पेडेस्ट्रियन अनि मिक्स ट्राफिक हुन्छ. इकोनोमी एन्ड एभाइलेबिलिटी अफ द मेटेरियल भनेको इनिसियल कस्ट, मेन्टेनेन्स कस्ट, कन्स्ट्रक्सन इक्विपमेन्ट, एभाइलेबिलिटी अफ द लोकल मेटेरियल्स. लोड एन्ड फोर्स एक्टिङ अन द ब्रिज भनेको ब्रिज एक्टिङ अन द फोर्स डिपेन्ड अन द आइआरसी. आइएस भनेको डेड लोड, सेल्फ वेट अफ द डे, गर्डर, वेयरिङ कोड, प्यारापेट्स, युटिलिटिज. इट एक्ट पर्मानेन्टली थ्रु आउट द लाइफ अफ द ब्रिज. लाइभ लोड. लाइभ लोड इज प्रोड्युस बाई द मुभिङ द भेहिकल्स अर पेडेस्ट्रियन. एक्जाम्पल ट्रक लोड, बस लोड, रेलवे लोड र पेडेस्ट्रियन लोड. इफ वान इज द मोस्ट इम्पोर्टेन्ट डिजाइन लोड. इम्प्याक्ट लोड. डाइनामिक लोड भनेको मुभिङ भेहिकल प्रोड्युस भेरिएसन एन्ड सक. देयरफोर इम्प्याक्ट लोड इज इक्वल टु लाइभ लोड प्लस डाइनामिक इफेक्ट. इम्प्याक्ट डिक्रिज विथ द इन्क्रिज इन स्प्यान लेन्थ हुन्छ. विन्ड लोड. विन्ड एक्जर्ट होरिजेन्टल प्रेसर अन डेक, गर्डर, भेहिकल फायर. इम्पोर्टेन्ट फर लङ स्प्यान ब्रिज, हाई ब्रिज, सस्पेन्सन ब्रिज. Longitudinal forces. These forces are act parallel to the bridge axis due to the vehicle braking, vehicle acceleration, temperature change, shrinkage and creep and earthquake effect. Lateral force matching. These forces are perpendicular to the bridge axis due to the wind, water current, centrifugal force, earthquake. Other important load भनेको seismic load, water current force, buoyancy force, earth pressure, temperature, stress, shrinkage or creep को. अनि त्यसमा पछाडि कोलिजन. ब्रिज लोड भनेको डेड लोड, लाइभ लोड अनि फेरि टेम्परेचर, विन्ड, अर्थक्वेक. कन्क्लुजन भने द सेलेक्सन अफ द ब्रिज डिपेन्ड मेनली अपन द स्प्यान लेन्थ, साइड कन्डिसन, फाउन्डेसन, रिभर क्यारेक्टरिस्टिक्स, ट्राफिक डिमान्ड एन्ड इकोनोमी. ड्युरिङ द डिजाइन अफ द रिलेभेन्ट रोड, डेड लोड, लाइभ लोड, इम्प्याक्ट लोड, विन्ड लोड, लङ्गिट्युडनल फोर्स एन्ड lateral फोर्स, इट मस्ट बी कन्सिडर्ड टु इन्स्योर द स्टेबिलिटी, सर्भिसबिलिटी एन्ड ड्युरेबिलिटी. Describe the factor affecting the permeability of the soil. How to determine the coefficient of permeability in laboratory and field. Permeability is the property of the soil which allows the flow through its interconnected void. The coefficient of the permeability denoted by the K and it is expressed in the meter per second or cm per second. Factor affecting the permeability: grain size, larger particle, gravel, coarse sand, higher permeability, fine particle, sealed clay, lower permeability. Void ratio, porosity. Higher void ratio provides a larger flow channel. Therefore, permeability increases with the increase in void ratio. Soil structure or fabric. Well-connected pores increase the permeability. Flocculent structures are generally more permeable than the dispersed structure. Degree of saturation. Fully saturated soil allows the easier water flow. Entrapped air reduces the permeability. Property of the pore fluid. Higher viscosity decrease permeability. Permeability increase with the increase in temperature because the water viscosity decreases. Soil compaction. The compaction reduces the soil space, hence permeability decrease. Minerals compositions. Clay mineral, especially Montro, Coronite having a low permeability due to the swelling and small pore space. Determination of the coefficient of the permeability. It is a laboratory method. Constant air permeability test suitable for the cross-grain soil and that constant air permeability suitable for the coarse-grained soil, sand and gravel clay formula. K is equal to QS by QL by ATS. Q is the quality of the water collected, L is the length of the specimen, A is the cross-section area, H is the constant, and T is the time. Advantage simple, accurate to the coarse soil. Falling at permeability. Falling at भनेको फाइन ग्रेन सोइल सिल्ट अनि क्लेको लागि के इज इक्वल टु 2.303 AL बाई स्मल AL बाई क्यापिटल AT लग H1 बाई H2 स्मल ए भनेको एरिया अफ द स्ट्यान्ड पाइप ए भनेको एरिया अफ द सोइल स्पेसमेन एल भनेको लेन्थ अफ स्पेसमेन H1 H2 भनेको इनिसियल एन्ड फाइनल रेट field method pumping out अथवा pumping in test used for the large scale for investigation. Water is pumped from the well and drawn down in nearly observation well is measured to determine the permeability. Pumping in test water is pumped in the ground suitable where groundwater level is low. Auger hole test commonly used for the shallow ground and the agricultural drainage investigation. Packer test, Luguen test used in the rock formation to determine the permeability. अब हामीले डिटर्मिनेसन अफ पर्मनेन्ट ल्याबोरेटरी मेथड र फिल्ड मेथड ल्याबोरेटरीमा कन्सटेन्ट र फलिङ एड फिल्डमा पम्पिङ टेस्ट अगर होल र प्याकर टेस्ट permeability is the key property of the design of the foundation dam canal retaining structure drainage system and the groundwater project if it depends on the soil characteristics and pore water property. The constant head test is used for the coarse soil to the falling edge test for the fine soils, while pumping test and the auger hole test are commonly used in the field. Define the pressure and center of pressure in the static liquid. Explain the center of pressure. Pressure always lies below the center of gravity and at any immersed surface. Take formula without derivation. 2, 3, 5 marks. The total pressure अथवा hydrostatic force total pressure is the resultant hydrostatic force exerted by the static liquid or the immersed surface. P is equal to gamma AS. P is the total hydrostatic pressure. Gamma भनेको unit of the liquid. A भनेको area of the immersed surface. S भनेको depth of the centroid below the free surface. Center of pressure CP. The center of pressure is the point on the immersed surface through which resulted hydrostatic force act. Center of pressure lies in the center of gravity. For the plane surface immersed in the liquids, HCP is equal to H plus Ig by AS. HCP भनेको depth of the center of pressure, S भनेको depth of the centroid, center of gravity, Ig भनेको second moment of area about the centroidal axis, A is equal to area of the surface. Since Ag by AS is greater than 0, therefore ACP is greater than S dash. That's where hence the center of pressure is always lies below the center of gravity of the immersed surface. Hydrostatic pressure increases linearly with the depth. Reason भनेको अर्को छ the lower portion of the surface experience greater pressure than the upper portion. Therefore, the resultant force shift downward, making the center pressure lie below the centroid. Free surface हुन्छ अनि सेन्ट्रोइड माथि हुन्छ अनि सेन्टर अफ प्रेसर तल हुन्छ इमर्स्ड सर्फेस भने चाहिँ के हुन्छ नि in static liquid total pressure is the resultant hydrostatic force acting on the submerged surface while center of pressure is the point of application because pressure increases with the depth and center of pressure is always located below the center of gravity of the immersed surface भनेर भन्यो। यसरी हाम्रो 5 वटा क्वेसन सकियो।